So good morning to all. So in the previous class, what we have done, we have calculated shear force diagram and bending moment diagram for cantilever beam. So in this class, what we'll do, we'll see a numerical on how to draw shear force diagram and bending moment diagram if the given beam is a simply supported beam. Simply supported beam. As you can see in this figure, this is a simply supported beam. The main difference between simply supported beam and cantilever beam is a cantilever beam is a beam where one end is fixed and another end is the free. This is nothing but your cantilever beam, whereas both the end are supported on the supports. Here we have two supports on which if we have a beam, it is nothing but simply supported. It is supported by two simple supports, so it is a simply supported beam. Now, here in this type of problems, we need to calculate the shear force and bending moment. Based on those data, we need to draw shear force diagram and bending moment diagram, which we have seen in the previous classes. So in this class, how to approach with the simply supported beam. Okay. Before that, as we know that before this, the sign conversion, I think you people know this sign conversion, right? For example, the sign conversion, if you are dealing with the shear force diagram, if the load is applied vertically downwards on a beam, we take it as positive sign. If suppose if the load is acting in the downward direction, upward direction like this, then we need to take negative direction, negative sign for the shear force diagram. Similarly, for bending moment in a beam, if the load is applied in the downward direction, we'll take negative. If the load is applied in the upward direction, we'll take positive. This is the sign conversion which we have seen in the previous classes. Now, based on this, you can note down. Based on this, we'll solve now. For a given beam, if it is a simply supported beam, you just note down this. Have you note down this? सभी लिख लेना ये. Jawad, Khan Ayman, Ajit Rathod. If you have written this, you let me know. Okay. Now, the given beam is a simply supported beam. It look like this, right? Here we have some load on this. Here we have some point loads which are acting on this. So the beam you can see over here. Now, here first what we need to do, once whenever we approach with the problem, first we need to make the sections over there. So let us call this is section A, this is section B over here, this is section C, this is section D, and this is section E. So whenever we have a simply supported beam, we need to determine the reaction forces. We need to determine reaction forces which are acting at the supports. Like at this support and at this support, we have two supports A and E, and at this supports we have reaction forces. To determine the reaction forces, we should know that for a beam should be in equilibrium condition. A simply supported beam should be equilibrium condition. When it will be equilibrium condition? When the upward forces, when the downward forces, these are the downward forces. When these downward forces are equal to the upward forces, then only the beam will be in under equilibrium condition. So here we can write the reaction force Ra over here. Here we can write reaction force Re over here. The reaction force Ra plus Rb, this should be equal to, these are nothing but upward forces. This should be equal to the downward forces. Downward forces are nothing but, we have 3-point loads, that is nothing but 2 kilonewton plus 5 kilonewton plus 4 kilonewton.
Sir, RA plus RE or RB, sir?
This is Re. This is Re. Here we have E, right? Ra plus Re. Ra plus Re is equal to 2 plus 5 plus 4. is nothing but how much? 11 kilonewton. Here why we have done like this? Like as we know that we need to maintain a equilibrium here. To maintain the equilibrium, a beam, the upward forces should be equal to the downward forces. Now we need to determine what is the value of Ra, reaction force at Ra, reaction force Re. How we need to calculate these reaction forces? Let's see here. To determine reaction forces, what we'll do? Reaction forces. See, once you written this, have written this, Ra plus Re is equal to 2 plus 5 plus 4 is equal to 11 kilonewton. कैसा आया ये? Upward forces equal to downward forces. Clear? Now we need to determine what is the value of Ra and what is the value of Re. If you determine any one of these, you can easily calculate the another one. If you found out Re, you can easily calculate Ra. So first we'll go with Re. So how we can calculate here? As we know that summation of bending moment which are acting are equal to 0, means the bending moment about this point, like force into this perpendicular distance, this force into perpendicular distance should be equal to the vertical forces and its distance. Those things we'll see, you will understand over here. Summation of moment should be equal to 0. That's what we'll write. Like we have calculated already this one. Reaction force Re, this force into this direction till this. What is the length from here to here? What is the length? 1.5 plus 1.5, 1.5, around 6, right? Okay. Re into this, which should be equal to these forces, this force and this moment. This force into distance, this force into distance, this force into distance. What is this? Let's see. 4 kilonewton. This force into this distance. What is the distance from here to here? It is 4.5. 1.5 plus 1.5 plus 1.5, it is 4.5. Okay. Next, plus we have this force 5 kilonewton. It is at a distance from how much? From here to here. It is 3 meter. 3 meter. Next, here we have one more point load, which is nothing but 2 kilonewton into the distance is 1.5. Now this is nothing but your upward moment. These are nothing but your downward moment. Then only our beam will be in under equilibrium condition. Force into distance. This is upward moment. These are the force into distance. These are nothing but your downward moment. If you simplify this, you will get the answer. Simplify this and tell me the answer. Re into 6, which is equal to how much it will come? कितना आता देखो इसका simplify करो इसको 4 into 4.5. 4 into 4.5. How much? 18. It will be 18 here. This is 15. Next we have 2 into 1.5. It will be 3. Totally together. How much? 36, right? 18 plus 18 plus 18 is 36. Now here we have 6. You cross multiply with this, like Re into 6, which is equal to 36. Re is equal to 36 by 6. So Re is nothing but your 6 kilonewton. Now you substitute in this equation, you will get Ra is equal to 11 minus 6, which is nothing but how much? 5 kilonewton. So these reaction forces which are acting over here means at this portion we have Ra is equal to 5 kilonewton. At this portion Re is equal to we have 6 kilonewton. Is this understood or you want me to repeat this concept once more? सबको समझ में आया ना? और एक बार समझा दे इसको. मोहम्मद जवाद, विवेक,
समझ में आया सर.
समझ में आया ना? क्या और एक बार समझा बोले तो और एक बार बोलता हूँ. कुछ भी डाउट नहीं रहना सर किसी को भी. So whenever there is a simply supported beam, first what we need to do, we need to determine the reaction forces. Whenever there is a simply supported beam, we need to determine the reaction force. Let us for the given problem we have 3 point loads which are acting over there. Okay, the total length of the beam is how much? It is 6 meter. From here to here it is 1.5 1.5 1.5 meter 1.5 meter 1.5 meter. Okay, now here we have around 2 kilonewton, here we have 5 kilonewton, here we have 4 kilonewton. Now once we done with these things, next thing we need to make the cross sections over here. So let us call it as A, B, C, here D, it is E. Okay, then we should know that the upward forces is equal to downward forces. That is nothing but here we need to calculate the reaction forces Ra and Re. To determine Ra and Re, you should know that Ra plus Re is equal to the vertical forces. That is nothing but 2 plus 5 plus 4. How much? 11 kilonewton. Similarly, you can calculate Re. These are nothing but forces. Then we are considering with the moments. Re into the length is 6, which is equal to this 4 into 4.5, because it's 4 into this distance. Next we have this one 5 into 3 plus 5 into 3. Next plus 2 into 1.5. 2 into 1.5. All together you will get a 36. So Re is equal to 36 divided by 6. So Re is equal to 6, which is acting at this support. Similarly, if you substitute this in this equation, you will get Ra, which is nothing but Ra is equal to how much? This is 5 kilonewton which acts here, 6 kilonewton which acts here. Is this understood? Clear? Jawad, Khan Ayman,
हाँ सर
Vivek.
समझा सर.
Okay, fine. Once it has been done, the next step, we need to determine the shear forces at each point. We need to determine shear forces at each point. Okay, we'll rub this for a moment. We will calculate shear force at each sections. Okay, now tell me, what is the shear force which is acting at a point E? Shear force which is acting at a point E. Anybody? Zero. How come it is 0? See, we'll calculate shear force which is acting at a point E, means at this point. Here one thing you need to write, reaction at A. What is the reaction force at A? It is 5 kilonewton, right? So reaction force at here, reaction force at E is equal to 6 kilonewton. Okay, then now shear force which is acting at a point E. Here we have a reaction force which is acting here in the upward direction, so it should be minus 6 kilonewton. If it is acting in the downward direction, we will take positive. Is this understood, right? Shear force which is acting at this point E is minus 6 kilonewton. What about shear force which is acting at point D? Shear force which is acting at this point. That is nothing but again minus 6 kilonewton plus 4 kilonewton. This is positive, downwards in the sense positive. So together it is minus 2 kilonewton. Next, shear force which is acting at this point C. Minus 6 plus 4 plus 5. How much? Plus 5, yeah. 3 आएगा. How much? 6. 5 plus 4 is 9. 9 minus 6 is 3. 3 kilonewton. Next, shear force which is acting at a point B. At this point. Those are nothing but summation of vertical forces which are acting left to this. That is nothing but minus 6 plus 4 plus 5 plus 2, which is nothing but how much? 9 plus 2 is 11. 11 minus 6 is plus 5 kilonewton. Similarly, shear force at point A is equal to plus 5 kilonewton. The same thing will carry forward here. The same force will carry forward here. 5 kilonewton. Is this understood? Vivek, Khan Ayman, is this understood?
Sir, at point A, the reaction force is 5 kilonewton, no, sir?
किधर बा?
At reaction, ये point A पे.
See, the force which we have calculated at this point, it is 5 kilonewton, right? At this point, this force will carry forward till this, and this force will carry forward till this, but we don't consider this force. There is a, you just remember this point, don't forget this. We don't consider this force. This force, whatever the force which is acting at this point, it will be carry forward till this. You remember this point. Okay. Shear force at point E is minus 6 kilonewton. Shear force at point D minus 6 plus 4 is minus 2 kilonewton. Again, the shear force at point C minus 6 plus 9 is nothing but plus 3 kilonewton over here. Shear force at point B is minus 6 plus 11 is nothing but over plus 5 kilonewton. Similarly, this force will continue till shear force at point A, that is nothing but plus 5 kilonewton. Once you have done with this, the next step, what we need to do? We need to draw shear force and bending moment diagram for this. Again, this is the simple step which we have already done in the previous classes, right? What we need to do here, first we'll take the reference line. Let us take a reference line which is parallel to given beam. Let us take this is a reference line. Once it has been done, the next step what we need to do, we need to take the magnitude lines, like shear force at point E. It is shear force at point E is minus 6. So you write down minus 6 over here, minus 6 centimeter in the downward direction. If it is positive, you need to write in the upward direction. At this point D, it is 2 kilonewton, minus 2. At this point C, we have positive 3. From here to here, it is 3 kilonewton. Okay. From here to here, it is 3. Next, shear force at point B is 5. From here it is 5. Shear force at this point also it is. Now once it has been done, the next step is we need to add this. Like what we need to do is, since we have point load, all the lines are in the parallel to the beam. All the lines are parallel to the beam. So like this it comes. All the parallel lines है, कौन सा भी inclined नहीं है, सभी parallel line है. Here you need to mention the values. It is 5 kilonewton over here. It is it is 5 kilonewton over here. Here it is 3 kilonewton. Here it is how much? It is my 2, right? It is 2. From here to here it is 6. Here it is 6. Okay, this is how it look like. 6, 6, 2, 3. Okay, fine. Is this understood now? समझ में आ गया ना सबको भी? Any doubt over here? Jawad, Khan Ayman, Vivek. Khan Ayman. Jawad.
नो सर,
समझ में नहीं आया?
नहीं समझ में आया सर.
नहीं आया तो पूछ दो, मैं कौन सा भी नहीं आराम से बताता हूँ और एक बार बताता हूँ. सिंपल है, टॉपिक बहुत सिंपल है. ये बच्चे सो कहाँ है नहीं, ये बच्चे खान अईमन किधर है, विवेक किधर है, बच्चे म्यूट में करके कहाँ तो गए क्या?
पता नहीं.
Okay, fine. So once we have done with this, next what we need to do, we need to determine the bending moment. Is this understood, right? Clear है ना सभी? ये इसमें क्या तो doubt है?
नहीं सर.
Okay. Once we have done with this, next we'll go to the bending moment diagram. Okay. To determine the bending moment, again, see, moment is nothing but a force into perpendicular distance, right? The sign conversion you should know. What is the sign conversion? If there is a beam, if the vertical force is acting, for the bending moment diagram, what we will do, we will take the vertical downwards as the negative and upwards as positive. Upwards as positive. Clear? Now we need to determine what is the bending moment which is acting at point E. Bending moment which is acting at point E, at this point. Okay, so we know that we have a force which is acting here, which is nothing but 6 kilonewton. It is positive because upward forces are positive, downward forces are negative in terms of bending moment. Into force into distance, moment is nothing but force into distance. Distance means we are calculating at this point, means the distance is 0, so it will come 0 kilonewton meter. Next, bending moment which is acting at this point, that is nothing but D. At this point D, we have the forces, this upward force and this downward force. This upward force is nothing but a positive 6 kilonewton into the distance is 1.5 from, it is at a distance of 1.5. 1.5. Next, negative, we have this one 4 kilonewton, 4 kilonewton, and which is acting at this point, in the sense the distance is 0 at this point itself. So this will be your 0, the entire thing gets 0. And what about this 6 into 1.5? around 9. Yeah, I think it is right. 6 into 1.5, it is 9 kilonewton meter. Similarly, you need to calculate bending moment which is acting at point C. Bending moment which is acting at the point C, which is given by, here we have this reaction force, that is nothing but 6 kilonewton. From here to here, it is acting at this force into perpendicular distance. This force into perpendicular distance is 3. Next, we have this force which is acting from here to here, that is nothing but minus, this is upward downward force is minus 4 kilonewton into the distance is 1.5. Next, at this point we have this force, means it comes 0, that is nothing but minus 5 kilonewton into 0, because it is acting at this point itself. We are calculating at this point, so it comes 0. So now how much it will be? 4 into 1.5, how much? 4 into 1.5, it will be 6. So together it will be 12 kilonewton, right? At this point, this is positive. Similarly, at this point, bending moment at point B. Bending moment at this point is nothing but again this 6 kilonewton reaction force into, from force into the distance from here to here, it is 1.5, 1.5, 1.5, it is 4.5. Next, we have this force which is acting from here to here. So force is nothing but again the downward force is negative 4 kilonewton into the distance from here to here, it is 3. Next, here we have one more force from here to here, it is 1.5, that is minus 5 into 1.5. Altogether, what is the answer? It will be 12 kilonewton. You check it now. सिंप्लीफाई करो और देखो इसका आंसर कितना आता है. ओके, now similarly determine the bending moment at a point, this point A. So how we can calculate here? Again, this is 6 into the distance, total distance, because we are calculating at this point. 6 into 6 minus this 4 into, from here to here, what is the distance? 4 into 4.5. Next,
सर सी
minus
कैलकुलेट करें सर.
5 into 5 into 3. Next, we have minus 2 into 1.5. Now all together, what is the answer here? At point A, it will be 0. कैलकुलेट करके बता दो जवाब क्या है, आंसर देखो.
यस सर.
आंसर क्या आ रहा है देखो. 0 आ रहा है, नहीं मालूम होता. जीरो आ रहा नहीं, एक बार देख लो, बता दो मुझे.
सर कौन सा जीरो आना सर?
बेंडिंग मोमेंट एट पॉइंट ए.
जीरो आना सर.
जीरो आ रहा है कि नहीं,
हाँ
चेक
सर
कर.
जीरो आया सर.
आया ना,
आया सर.
क्योंकि वो तो ये 36 into 6 is 36 माइनस
15
ये
माइनस
माइनस ये कितना है 4 into
प्लस होता
4.5
सर.
के 4 into 4.5 कितना आता है, ये -18 आ गया, और इधर माइनस ये 15 आ गया. और ये माइनस
-3
3, सो ऑल टुगेदर कितना होगा ये 18 प्लस 18, ये दोनों मिलाए तो 18 प्लस 18 बहुत तो 36 minus 36 which is equal to 0. So bending moment at point A is 0. Clear? Bending moment at point E कितना आ गया पहला, इधर 0 आया. Bending moment at point D कितना था वह
9 किलोमीटर
9 किलो न्यूटन मीटर. Bending moment at point C
12 किलोमीटर.
C is 12.
Yes
Okay,
sir.
C is 12 kilonewton meter. Next bending moment at point B, ये भी 12 आया था ना, 7 आया था.
नहीं सर 6.5 आता.
7.5.
7.5, very good. ಯಾರಪ್ಪ ಈಗ ಬಂತಲ್ಲ ವಯಸ್ಸು 7.5 kilonewton meter. Okay, bending moment at a point A is 0. थोड़ा मैं मिस्टेक किए तो केयरिंग है ना. एट बेंडिंग मोमेंट एट पॉइंट बी 12 बताया था ना मैं जोश में. एक बार सिंप्लीफाई करके देख लो, मालूम हो जाता है. और एक बार बता बोले तो बता दो. देखो सी है बेंडिंग मोमेंट एट दिस पॉइंट. बेंडिंग मोमेंट एट पॉइंट B, how it's 7.5. Bending moment at point B is nothing but this 6 into the distance is 4.5. Next minus 4, this 4 into this perpendicular distance is 3. Next minus this 5 into 1.5. 5 into 1.5 all together. So how much? 6 into 4.5. This is 27 minus 12.
8.5 आता सर वो. 8.5 आता.
8.5 आता है. चेक कर लो इसको, देखो 27 minus
57 सर
12
12
minus
minus
7.
7.5.
हाँ, equal to 7.5 आता है.
27
27 minus 12
आता
minus
सर.
7.5. You will get 7.5 is the answer. चेक करो एक बार, चेक करो. इजी. 12 प्लस 7.5 कितना हो गया? 19.5 हो गया. माइनस 27 करो, उसमें कितना हो गया? 7.5 आ गया. ओके, so at this point it is 7.5. Once it has been done, the next step what we need to do, we need to draw the bending moment diagram. For that what we need to do, we need to take a parallel line which is parallel to the given beam. After this we need to plot the magnitudes at this point E. At this point E we don't have any like bending moment, means bending moment at this point is 0. You can see. Next bending moment at a point D is how much? 9 kilonewton, means at this point 9 kilonewton. It is positive 9 kilonewton. At the point C we have 12 kilonewton. At point C we have 12 kilonewton. At point B we have 7.5. At point B we have 7.5. At point A we have 0. It is 0 over. Next we need to add this. So here make sure that it should be like we are calculating bending moment diagram. So bending moment diagram में point load को कैसा denote करते हैं? We denote by inclined lines. We denote by inclined lines, right? This is nothing but the bending moment diagram for the given loading condition. Here you need to mention the values. Here 0, it is how much? It is 9 kilonewton meter over here. It is 12 kilonewton meter over here. It is 7.5 kilonewton meter over here. It is 0 over. This is positive. All are in positive. All are in positive. So this is your bending moment diagram. So I hope so you understood the concept of solving a shear force and bending moment diagram for simply supported beam. Now in the tomorrow's class we'll start with when a simply supported beam subjected to UDL and simply supported beam subjected to UVL. And apart from this, we have a couple. If we calculate these three forces on a simply supported beam, we supposed to complete this model, complete model. Like we'll solve, apart from this, we'll solve some question per numericals. Clear? Any doubt?
Yes, sir.
Any doubt?
No, sir.
Vivek?
No, sir.
Jawad?
नहीं सर.
What about this Khan Ayman? ये कहाँ है वो बच्चा, ये साउंडिस्ट नहीं कर रहा तो क्या भी है गया. Okay, you tell your friends to join the classes. If they miss the class, they won't understand. Okay.
सर ऑफलाइन क्लासेस में
Now
क्या हुआ सर?
offline classes final year का चल रहा है ना अब.
सर हमारा
ना तुम्हें HOD सर की बात करना है एक बार. HOD सर को मिलो, मालूम हो जाता है.
फिर एग्जाम तो ऑफलाइन होने वाले ना सर.
हाँ, एग्जाम्स ऑफलाइन होता है.